please welcome Microsoft Senior Vice President, Server and Tools Business, Bob Muglia.
Good morning. Good morning. Welcome to IT Forum. It's a great day. That capability now with Virtual Server R2 for you to take advantage of that. With that, what I'd like to do is invite Josh Cohen up to give us a demo of Virtual Server R2 and Windows Server R2 together and some of the failover capabilities that we've built in. Josh.
Hi, Bob.
Morning.
Thank you. Today, we're going to show an example of a self-managing dynamic system using the new R2 technologies. That's Windows Server 2003 R2, Microsoft Clustering, Virtual Server, wsmanagement, and MOM. So in order to do that, we've brought a set of machines on stage here for a virtual data center. We've got our Dell server right here, which has MOM running on it. You can see the MOM screen behind me, which has a map of our network here on stage. Now the bottom part is the clustering service, which we're going to go ahead and look at over here, which is provided to us by HP. Now in this rack, we've got 2 per-alliance servers along with a StorageWorks SAN connected by fiber. Now these servers have been outfitted with a prototype version of wsmanagement, which allows the system to be managed from a hardware and software perspective.
Now, Windows Server R2 builds in support for wsmanagement. Wsmanagement is a standards-based protocol that allows for heterogeneous management of both hardware and software. We're working with the hardware industry all up to build in support for wsmanagement into their solutions. Wsmanagement will be used for offline management of systems that are not in a running state, but it also can be used for managing systems that are in a running state, such as this demo.
That's right. So for our first example, we're going to show how it all works together to provide an automated response to maintain service availability in the face of a hardware problem. So if you give me a hand, Bob, we're going to make some damage. Okay, so if we take a look on the screen here, on the top, we've got the clustering status. On the top, we've got node 1, which has a web server workload. And on the bottom, we've got node 2, which has a printer and NT4 workload. So pay attention to that as Bob pulls the fan here.
Creating a little hardware failure.
That's right, impending problem. So what's going on right now is that MOM is managing the system, again, from hardware and software, so it's able to monitor the OS as well as the hardware. So it should notice that system, and if you watch closely on the virtual server status, you'll be able to see it migrate once it notices. So as MOM monitors the system, we're able to see the service, and if we refresh this, now you can see on the virtual server status it's begun its migration. MOM has registered an alert on cluster serve 1, so I'm going to go ahead and troubleshoot this. I can see from the status in the error that it says 1 or more fans are reporting a failure. So that's what we just caused. And if I look at the history of this alert, it'll tell you what MOM did. MOM went ahead and actually caused the migration of that workload to be moved to the other server. So now, as you can see, it's migrated. We're going to go ahead and go back to the diagram, and at the same time, we're going to go ahead and fix the hardware problem.
So this is an important thing, because what we're doing here is we're integrating MOM together with Virtual Server, so that in this case, there's a failure, a hardware failure caused when I pulled this fan out, and that caused MOM to actually move the workload over. Now, if I replace that, this system should return to an operational state.
Yeah. Thank you. Okay, so now that that's fixed, now normally we come back and say, okay, well, everything's just fine, but it's not. If we look a little closely here, we can see that on cluster serve 2, there's now a warning. So let's investigate that. Well, okay, CPU processor exception. What this means is that for too long of a time period, the CPU has been used above a certain threshold. So if we examine why that is, it's because in order to keep the service up and available, MOM migrated the workload over to cluster serve 2. Now, in a normal situation, we wouldn't want that, but rather than have the service go down, we'll allow that. But what it did was it created the service exception. It's too much of a load for this server. So first thing I'm going to do is, since we fixed the hardware problem, I'm going to go ahead and I'm going to resolve this alert, since it's now fixed. And at the same time, now that we fixed that hardware problem, I'm going to be able to migrate that load back to the working server. So I'm going to run a MOM task, which is integrated with the clustering service, which is going to move that VM back from node 2 to node 1, restoring things back as they are. And as you can see on the status pages, you can see the migration is in progress.
So all of those task integration, all of the ability to do that level of migration, things are all built in, and you can use the MOM console to drive that from a single operational space.
That's right. So I'll go ahead and I'll resolve this alert.
So in this case, we caused a problem, it was resolved, but we had some time, right? Because the fan failed, the system wasn't really in a state of failure. We were able to migrate a workload over in a controlled fashion to the other machine. But what happens if we lose power on a machine and it goes down entirely?
Well, then things get a little different. So you can see Bob's cut the power. That switch actually cuts the power from the server. And as you can see, the video output on that is now black. So there's nothing going on in that server. The bottom one is still going. So at this point, you can see that it's not working, and the screen is blank, and it did not have a chance to save the state. Now, this is one interesting feature of this, which is differentiating. This service does not require that the application or service that you're working with is actually aware of the clustering service. It's all transparent. So any app, any service, any operating system can be clustered in a high availability way on these systems. And that can be run on off-the-shelf hardware and off-the-shelf storage. So if we go ahead and we take a look at the cluster service manager, you can see in MOM there, it's already registered a problem. Now we can see that cluster serve 1 is now offline. That's offline because it's
not there anymore. Yeah.
It's dead.
It's dead.
So now if we look at cluster serve 2, we can actually see both on the screen behind me as well as on the console here that the web server load has been migrated to cluster serve 2.
So great. So with the combination of Virtual Server R2 as well as Windows Server R2, we're really delivering a full set of high availability solutions. The demo we just showed here, the migration of workloads in a controlled fashion, but in particular, the migration of workloads in the event of a catastrophic hardware failure, that's industry leading. No one else has the ability to provide that set of high availability features with their software. So we're really focusing on taking a leadership role in the virtualization space.
That's right. So Windows Server 2003 R2, Virtual Server 2005 R2, MOM, and wsmanagement and clustering gives you a self-managing dynamic system.
Great. Thanks a lot.
Thank you.
Thanks.